So this is the start of Unit 4. Now, Unit 4 is global systems and energy. Okay, energy is like the theme in basically every unit. Okay, in this unit, what we're basically looking at is how do all the different kinds of energy that we've gone over in chemistry, biology, and physics interact to produce a global environment that is supportive of life. Okay? The prime place where we see evidence of energy is in climate. Okay? In the prevailing weather conditions at a location. Okay? That is based on how much energy we receive, how energy is transferred to us, all of that kind of stuff. Okay? So today, hopefully this is going to seem familiar, okay? But we're going to go over what climate means, okay? What kind of things can impact it, that kind of stuff. Okay, so we're going to look at the components of climate. There are 4. Okay, what would be, if you were looking at the weather this morning on your weather app, what 4 things would you want to know?
If it's going to rain.
If it's going to rain, the temperature? Okay, yes, UV. Not one of the 4 components, but it's part of one of the components, and that would be light. Okay, so how much and intensity of light. And what would the last thing be?
I would look for like what it actually feels like.
Okay, so the humidex, okay. That's just a thing that we perceive, but it's not actually, like, it has to do with temperature, but it's not really, it's just a perceived thing. The wind, exactly. We get tons of that around here. Is it going to be windy or not? Do I have to worry about, opening my umbrella and having it go backwards? Okay, things like that. So those are our 4 components of climate: temperature, precipitation, light, and wind. So is it going to be sunny or cloudy? Okay, that kind of thing. It's a bit more advanced than that, and we'll talk about it. But basically, climate comes down to those 4 things. Okay, is climate the same everywhere? Absolutely not. So that means that those 4 components of climate are influenced by a number of different factors. That's the second thing we're going over today. Okay, is what are the factors that make an area's climate the way it is? How do they influence its temperature, precipitation, light, and wind? Okay, that'll be kind of super important for some of the analysis questions that you're going to get on a unit exam in this unit and on your final as well. Okay, so the 4 components of climate, as we said, are temperature, precipitation, light, and wind. Make sure you have that written down, highlighted, put a star beside it, whatever. Okay, you must know those 4 things. And here's why you must know those 4 things, as well as the factors that affect climate that we're going to talk about later. On your unit exam, I will put a question on there that has a map of Canada. Okay? And I will pick a Canadian city. And in case you're geographically challenged, I will put an arrow pointing to it so you know where it is. Okay? And I will ask you, based on what you know of factors affecting climate, describe the climate of this city and why it would be like that. Okay, so in that explanation, you would have to talk about some of the factors that we haven't talked about yet. Okay, and how they would make the temperature, precipitation, light, and wind the way you think they would be in that area. Okay, don't worry, I'm going to pick somewhere that's not obscure. Okay, like I'm not going to pick, Tuktoyaktuk or something like that. Okay, or some tiny little hamlet in the middle of Manitoba. Okay, I'm not going to pick something obscure. I'll pick a pretty major place, and the factors will be fairly obvious. Okay. All right. So components: temperature, precipitation, light, and wind. So the other thing here, guys, definition of climate. Climate is the prevailing weather conditions at a location. Okay? Not to be mistaken with averages. A lot of people say the climate is the average this or the average that. It is absolutely not. Okay? If it was, describing the climate of Okotoks would sound like this. The climate of Okotoks is that the temperature is 4 degrees Celsius. The wind is from the southwest at 25 kilometers per hour. There are 12 hours of sunshine and 12 hours of darkness every day. Okay, and we'll get about 1.5 millimeters of rain. Does that happen every day? That's why averages are done. Okay, climate is not the averages for Okotoks. We probably never have a day of the year where that is all true. Okay, those are the average numbers, but that's not what goes on here. Okay, climate is what could you expect today? Okay, well, today is June the 2nd. Okay, so we could expect that the temperature is probably going to be somewhere around 17 to 20 degrees Celsius. That's a pretty normal temperature for this time of year because we're going to get a fairly long day, right? Probably about 16 hours worth of light today, because we're coming up on the summer solstice. Wind typically comes out of the southwest. We'll probably get some of that today. Okay, and based on this time of year, June is actually our wettest month here in Okotoks, so we could probably expect a few millimeters of rain today. Okay, but if I described that for December 2nd, it would sound a lot different, right? We would expect the temperature to probably be -8. Okay, that there would only be probably around 8 hours of daylight, okay, and that we could maybe expect a little tiny bit of snow. That may or may not happen, but that's one of our drier months actually, okay, that kind of thing. And again, wind probably out of the southwest. That sort of makes sense? So climate is the prevailing weather at a location for that time. Okay, climate doesn't describe averages. Okay? That's why when we talk about things like climate change, okay, we're saying, look, what I expect for this day is not what I'm typically getting anymore. Okay? Or what I expect for this day or for this season is typically not happening. It's changing. Okay? It's hotter and drier. Those kinds of things. Does that sort of make sense? Okay? So climate is not the weather. Climate is what you could expect for that area. Okay, based on history, location, and things like that. Okay. All right. What's going on in this picture? What kind of cloud? A thunderhead? What's the technical name for that? Cumulonimbus. Yeah. Okay. Cumulonimbus cloud. This is the time of year where we get those. Right? You start to get into June and July. That's our thunderstorm season. Okay, there's lots of humidity in the air during this time of year. There's more hours of sunshine, so there's more energy available to fuel these storms. Okay, so we typically get them. We don't typically get them in January. Okay, there isn't enough energy, there isn't enough moisture. Okay, it just doesn't happen for that time of the year. Right? So for this time of year, yeah, we could definitely get these, but it is an interaction of those climate factors. Or sorry, those climate components, sorry. Okay, those climate components are going to be a certain way. There's probably not going to be a lot of wind. You don't typically get thunderheads on a windy day. Okay, it's going to have to be fairly hot because we need the energy to drive the building of these storms. Okay, we're going to get precipitation because they produce that, but there's also got to be a fair amount of humidity, to build one of these. Those factors all have to be, I keep saying factors, those components still have to be a certain way to produce these storms. Okay, in the wintertime when we get one of those big snowstorms, where we get a 20-centimeter snowfall warning, those components are still temperature, precipitation, light, and wind, but those components look different. Thomas, enough. Shut it. I'm teaching.
Okay.
You're not paying attention, and I'm tired of it. Okay, so we've got those same components, but they're different. In the wintertime, in order to get a big storm like that, we have to have moisture coming in from somewhere else because we don't have it. We've got to have cold air moving in from a different direction, so our wind direction has to be different, typically northeast. Okay, all of those things are different, okay, to produce that different type of expectation for weather. Okay. Now, for one of these, okay, for a thunderhead, the way they build, you got that warm, moist air moving upwards, okay, and as moisture moves upwards, the temperature decreases, okay, and that water vapor will do what? What do you call it when it turns from a gas to a liquid? Starts with C. Condensation, right. So that water vapor will condense. Now, once it's a liquid, gravity is going to pull it. It's going to try to fall down. But in a thunderhead, there's too much lifting from below of the warm, moist air. So that'll actually push those water droplets back up into the cloud. Okay? So they'll actually run through this cycle a number of times. Okay? Every time that water droplet runs through the cycle, it gets a little bit bigger. Okay? That's why in a thunderstorm, you typically get like the big drops, the big raindrops, right? And like torrential coming down. Now, if that goes through even more, okay, eventually they might get way above the freezing point and turn into hail. Can hail go through that cycle a few times? That's how hail gets bigger. Okay? Next time it hails, stay inside. And then when it's done, go outside and grab one of the stones. Okay? Just give it a little tap on the sidewalk with a hammer. It'll split open and you'll be able to see layers like an onion, okay, on the inside. How many layers tells you how many times it went through that cycle. Once the droplet freezes, every time it goes through the cycle, more water vapor condenses onto the stone. Okay, and it grows, and it goes through again, it grows again, and you'll actually see those layers of deposition on the hailstone. Okay, so a golf ball sized hailstone, okay, that's probably gone through the cycles half a dozen times. Okay, you get some, that are baseball, okay, they've probably gone through a dozen times. Okay? It takes a lot to grow them to that size, so you have to have a pretty extreme weather event to get hail at all, but significantly sized hail, it requires a lot of that energy. Making sense? All right, so factors that affect your climate. Okay, factors that affect your precipitation, your temperature, your light, your wind. Okay, the number one factor that affects climate, number one, most important by a country mile, okay, is latitude. Where are you in relation to the equator? Okay, that is the number one factor affecting climate. Okay, so the reason latitude is the most important factor affecting climate is because the intensity and amount of solar radiation received changes based on where you are on Earth. Okay, if you are at or near the equator, the sun is directly overhead, so you get intense solar radiation coming in and hitting a small area. Okay, so something like this, okay, hitting this small area. So that's high intensity sunshine. Now, every one of these yellow bars represents the same amount of solar energy. But as you go away from the equator, the area that solar radiation covers gets bigger. So you're spreading that radiation out over a larger area, which reduces its intensity. Okay? So if you're getting less solar radiation, is it going to be colder? Okay? And we know that generally it gets colder as you move away from the equator. Okay? Now, we have seasons here. If the Earth is round, and it is, by the way, okay, and this works because it's round, why do we get summer here? Shouldn't it just be the same all year because of how much solar radiation we get? So what causes the seasons? Please say you know this. The Earth is tilted. Okay? The Earth's north and south pole are not straight up and down. Okay? it's tilted 23.5 degrees. Okay, so what that does is as the Earth moves around the sun, okay, so here's the sun, okay, the Earth's orbit, just going to draw like this, okay. So the Earth's axis is tilted. Now, sometimes the North Pole is tilted towards the sun, and sometimes it's tilted away. It's always 23.5 degrees, okay? But based on where you are in the orbit, that axis, the North Pole and the South Pole, point different ways. Now, because the Earth is round, when the sunlight strikes it, it can only strike the half that's directly facing the sun. Can't actually draw it on this one because it's within the plane here. Okay, so in this position, the North Pole is pointed towards the sun. So as the Earth rotates around its axis like this, what happens at the North Pole? The sun never sets. What day of the year would this be? The summer solstice. This is June 21st. We're coming up on this. Okay? On June 21st, the Earth's North Pole will be pointed as much towards the sun as it can be. And when it tilts, when it rotates around its axis like this, okay, the sun never sets at the North Pole. And it's when our days are the longest. Okay? Because we would be about here. So when we rotate around, we don't spend very much time on the dark side of the Earth. We spend more time in the sun. The opposite is true here. This is the winter solstice. How long are our days in the winter? Pretty short, okay? Because now the opposite is happening. The Earth is still spinning around on its axis, but we spend very little time in the sun. Okay? So not only do we get less hours of sunshine, but as the Earth tilts towards and away from the sun, the intensity of the sunlight changes. Okay? Coming up on June 21st, when the Earth's axis is tilted like this towards the sun, we'll be getting sun intensity more like that. Whereas on December 21st, when it's tilted like this, our intensity is even less than this one. It's probably over an area like that. Okay? And the intensity of the sun is much, much less. Okay? Colder temperatures. Making sense? So where you are on Earth, your latitude affects the intensity and duration of sunlight, and that affects your temperature. Okay, so that's two big components of climate, right? Temperature and light. Okay, they go together, they're both affected by the latitude. Okay? Okay, second biggest one, your altitude. Okay, snow's been gone here in Okotoks for months already. Is there still snow on the top of the mountains? Why? What happens to temperature as you go up? It goes down. Okay, so on the tops of the mountains, it's colder. Snow is going to remain there for longer. Okay, so about 6.4 degrees for every 1,000 meters of altitude. Okay, Okotoks, the altitude right here at this school is 1,096 meters above sea level. Okay, we are over 1 vertical kilometer higher than Vancouver. Okay, the higher up you go, the colder it's going to be. Obviously, if you go into the mountains, it'll be colder there. Snow will persist longer because of that. Okay, to give you kind of an example here, all right, so I took this picture before you were born, okay, in 2003. Okay, this is Mount Robson. This is the highest peak in the Canadian Rockies, all right. We started our day down by the plug-in over there, okay, at an altitude of about 1,400 meters. When we left camp, it was about 13 degrees Celsius, and it was raining a little bit. Okay? When we got to this pass here, okay, we were at an altitude of about, I want to say about 2,050 meters. Okay? Here, the temperature was about 6 degrees, and we were starting to see a little bit of snow. Okay? We'd only come up about 600-700 meters, but the temperature had already dropped, almost 8 degrees. Okay? And we were starting to see a change in the precipitation. People who made summit attempts that day on the top of Mount Robson, okay, which is over 3,000 meters above sea level, okay, were reporting temperatures in the -15 to -20 range with whiteout blizzard conditions. Okay? None of us were we were all kind of within a 5-kilometer radius of distance. But we were all experiencing very different temperatures just based on our altitude. Okay? The higher up you go, the colder it's going to get. Okay? All right. So if you were at a place at sea level, could you expect that to be typically more mild than a place like Calgary, okay, or Okotoks that are almost 1,100 meters? You definitely could. Okay, so there's 2 points on this, but they go together. All right. Third factor, distribution of land and sea. Are you close to a body of water, a major body of water, not like a pond? Okay, so it's not like this thing in Crystal Shores over there. Okay, that doesn't count. It has to be a big body of water. Okay, that can definitely affect precipitation, because it's a source of moisture. Okay, it can affect temperature. Okay, and to an extent, it can even influence wind. Not going to have much effect on light. Yeah, leave your phone.
Just on my desk.
Okay, so if we're comparing, let's say, Calgary and Vancouver, okay, there's obviously a difference in altitude of 1,100 meters or so. Okay, one's at sea level, we're not. But the bigger factor here is that Vancouver is on the ocean. Okay? And the ocean can greatly influence not only how much precipitation you get as a source of moisture, but also your temperature. Okay? So if you're in Vancouver, next to the ocean, okay, how much snow does Vancouver get? Almost none. If they get snow there, the city shuts down. They don't have plows, okay, because they just don't get snow. You go a little bit up the mountain from there, yes, you can definitely get snow there. But the city of Vancouver, okay, does not get any snow, okay, low or very little. And the reason for that is the temperature rarely drops below freezing in Vancouver. It's actually like one of the warmest places in Canada. Okay? The reason for that is this. The second law of thermodynamics says that energy flows from hot to cold, yes? Okay, so if the air temperature in Vancouver starts to drop, it can't drop any lower than the temperature of the ocean. Because as soon as it does, heat will flow out of the ocean and into the air and maintain a balance. Okay? So, lots of times, really cold air goes to Vancouver, but it gets warmed up by the ocean. The ocean is what we call a heat sink. It can store a lot of heat. Okay? Water has this ability to store huge amounts of heat and not change its temperature very much when it gives it away. So, as that cold air moves over, the air can't absorb nearly as much heat as the water can give. Okay? So the water will change temperature very little or not at all, but the air temperature will change a lot. It'll warm up and it'll regulate the temperature. Okay? Everybody kind of follow me there? So being near an ocean can generally, not always, create more mild conditions because it will regulate the temperature. Now, on the other side of that, it rarely gets extremely hot in Vancouver either, because if the air temperature gets higher than the ocean, then the energy flows from the air to the ocean. Okay? You can't stop the second law of thermodynamics. It's just going to happen. Okay? So being next to a large body of water, a major sea, okay, or an ocean, or even like one of the Great Lakes, okay, can affect your climate greatly. Okay, now I bring up the Great Lakes because near the Great Lakes, okay, if you're in like Buffalo, New York, okay, and even some Canadian cities that border on like Lake Ontario, Lake Erie, okay, things like that, they get what we call lake effect snow in the wintertime. If the wind comes in just right, it'll bring cold air across that body of water. But that body of water is warmer, okay? And so that cold air will come across and it will cause the snow to fall out very rapidly, okay, out of that cloud because of all the humidity that is produced by that lake. Okay? And so a place like Buffalo can get lake effect snow, and overnight they can be under 4 or 5 feet of snow. Okay? Just because that large body of water is holding a lot of energy, okay, that can help to produce huge amounts of precipitation. Okay? So being near an ocean can affect your temperature. It can affect your precipitation. Okay? Now, is it always a case of it makes it more mild? Does being near the ocean always mean you're going to have a more mild climate? Now, ask anybody from Newfoundland. Okay, my wife's from Newfoundland, right? And she would tell me about the days, but they would get snow days. I don't even know what those are. I live in Alberta. I've never had a snow day. Okay, they don't cancel school for anything around here. Okay? But she had talked about how they would get snow overnight, okay, over the course of a few days, and when they would open their front door, they would have to dig out of the house, okay, because the house would literally be like buried in snow. Right? They would get that much of it. They had to keep a shovel in their front closet, because otherwise you couldn't get, if you had your shovel in the garage and it wasn't attached to your house, you were digging out by hand. Okay, so they always kept a shovel in their front closet. I only know this because they opened up their front closet when we went to visit. I'm like, why is there a shovel in here? And it's for in the winter when we get all this snow. Okay, but on that coast, the ocean doesn't make the climate more mild. In fact, it makes it harsher. And that's because of point number 4. The nature of ocean currents. Where is the water coming from? Is the water warm or cold? So on the west coast, okay, of Canada, you've got the North Pacific Current interacting with the Alaskan Current. And what ends up happening is warm water actually comes up the coast of BC, okay, in and around Alaska here. Okay, this is where like Fort St. John is, okay, the wettest place in Canada, okay, is right in here. So that ocean current is always bringing warmer water, which creates mild conditions in BC. The opposite is true over here. You've got the Labrador Current, which comes out of the Arctic Ocean. That water is going by Newfoundland. Well, that's making the ocean colder. Okay? My wife, she has pictures of when the bays around them actually freeze over. Okay? Like the ocean freezes over. It gets cold enough to freeze the seawater, okay, in a lot of places in that area. And that's simply because you've got cold water coming out of the north instead of warm water. Now, if you look here along the eastern seaboard of the United States, this is where hurricanes are are always hitting. Okay, well, what's going on there? The Gulf Stream. Okay, a warm water current that comes out of the Caribbean. Okay, it's actually that warm water current that produces the hurricanes. There's a lot of energy in that warm water. That's what helps to build those giant storms. Okay, and then they come up. Okay, they hit Florida, right? They hit like, you know, the Carolinas, and then they generally peter out by about right here, but every once in a while they'll make it to Canada, okay? And then they kind of head out to sea. They run out of that warm water to keep them building, and they just die off. All right, making some sense? So if you're near an ocean, it can affect your temperature, positive or negative, based on whether it's warm water or cold water, okay? And being near the ocean can also be a source of moisture. Okay, can increase precipitation. That's not always hard and fast rule, okay, but in a lot of cases it is, based on wind direction. Okay, how many people have heard of these two ocean currents? Or talk of El Nino and La Nina? Okay, we talk about them all the time weather-wise here. Okay, in an El Nino year, we typically get mild conditions. Last year, okay, was an El Nino year. We had a mild winter. We didn't get a lot of snow. It was drier. Okay, that happens because of a current that actually forms way out here. Okay, there's an upwelling of warm water off the coast of Chile. Okay, and when that warm upwelling comes up, that's El Nino. Okay, El Nino will raise the temperature of the Pacific Ocean by 2 or 3 degrees. I know that doesn't seem like a lot, but when you consider the volume of water we're talking about, 2 or 3 degrees represents a colossal amount of energy. Okay? And that can affect our weather thousands of kilometers away. Okay? We'll get warmer weather and less precipitation. Now, that will peter out and it'll flip-flop. Okay? And you'll get cold water coming in to replace it. That's La Nina. If we get a La Nina year, that's going to be wetter and colder. Okay, so 2013, when we had our huge flood here, that was a La Nina year. We had a massive snowfall that year, and we had a very long, cool spring. And then all of a sudden, it just started to pour rain in June. Okay, it melted all the snow in the mountains, and it all just came rushing down all at the same time. Okay, so in an El Nino year, we typically get droughts and fires. In a La Nina year, we typically get higher water, flooding, okay, things like that. Okay. All right, now this is one that affects our climate in a huge way. Yes, just leave your phone, please. Okay, presence of mountain barriers. Okay, obviously we're right next to the mountains. This has a huge effect on our climate. Okay, so most of Alberta is located in what we call the rain shadow of the Rocky Mountains. Okay, the Rockies obviously run along our western border. Okay, winds here typically come out of the west-southwest, so they're bringing air from the Pacific Ocean. Okay, well, that air from the Pacific Ocean is laden with moisture. It's got tons of moisture and precipitation potential in it. The problem is, it's got to go up and over the Rockies before it gets here. Okay? And that's why BC and Alberta look very different in terms of the plants that grow there. Okay? BC gets way more rainfall and snowfall than we do because that moist, warm air that's coming in off the ocean gets pushed up to go over the mountains. But as it gets pushed up and it cools, most of the moisture in it condenses and falls on BC, on what we call the windward side of the mountains. So by the time it gets up and over the Rockies, it's all out of moisture. And we've got this cold, dense air sitting on top of the mountains. Okay, now, gravity likes to pull on heavy, dense things. Okay, so it pulls on this cold, dry air, and it runs it down the mountainside. Okay, there's a fair amount of friction between this air and the mountains as gravity is pulling that cold, dry air down the mountains. So it continues to be dry, but as it comes down the mountains, it warms up. causing a Chinook. Okay, this is how Chinooks are born. Okay, Chinooks are a localized phenomenon. Okay, if you talk to somebody who's not from here and you use the word Chinook, okay, they'll probably ask you if that's like a First Nations term or something because they've never heard it. Okay, and they just figured something like that. Okay, and it is actually, but they don't know what it means. They've never experienced it before. Okay, it's localized because of the nature of the mountains. You ever notice how you get that really sharp cloud band before a Chinook arch? Okay, it's like clear over the mountains, but there's this big wall of cloud that has a perfectly defined edge. Okay, the reason for that is all the pressure. Okay, anybody get headaches when we're going to get a Chinook? Okay, if you suffer from migraines, it's like the worst time. Okay, so that dense air comes down and creates a huge amount of atmospheric pressure that keeps the sky clear. On the other side of that, okay, all that lower pressure air has just been pushed into one place. That's what makes that sharp cloud. Okay, and then that warm air comes off the mountains, and we get that nice warm relief of winter, okay, that we enjoy around here. Okay, but people who are not from here, they don't know what that is. Leonardo DiCaprio, prime example. Okay, this guy like absolutely tried to cancel Alberta when he was here shooting The Revenant. Okay, we got a Chinook one of the days he was filming. Okay, started out, he went out on the job and it was like minus 15, and within a couple of hours it was 20 degrees Celsius. And he immediately went to, well, it was Twitter then, it's X now. Okay, immediately went there and it's like, I witnessed climate change firsthand. Meanwhile, everybody in Alberta is going, idiot. Climate change is the long-term change in weather patterns over hundreds of years. You saw a Chinook. That's weather, doofus. Okay? He got absolutely roasted by everybody in Alberta because he doesn't know what a Chinook is. Okay? He thought it was climate change because it fit his agenda. Okay? But it totally wasn't. That's weather. Okay? Climate change is a thing, for sure. And I'm not like a denier of that. It is just, that's not what that was. Okay, that's weather. That's a Chinook. We get those all the time. We're not afraid of them at all. Okay, but it's scary the first time you see it. Okay, everybody with me on that? Okay, so mountain barriers. This is a big deal. Okay, and they're not just here. Okay, this is the Gobi Desert here on the right-hand side of this picture. These are the Himalayas. Okay, you can imagine the Himalayas are 3 times taller than the Rockies in general. Okay, there's all kinds of jungle and stuff like that on the windward side of the Himalayas, but moisture doesn't get over them. It all drops onto them, and on the other side is a cold, dry desert. Okay, a rain shadow that you can see on the satellite pictures. Okay. All right, patterns of prevailing winds. Okay, we might not get all the way through this. Okay, obviously our prevailing winds here are west-southwest. That means they typically bring the same kind of weather. Okay. Changes in pressure can change the wind and then change the weather, which we get here all the time. Okay, so these two things interact. Typically, we just get our wind from the southwest. But if the wind comes from a different direction on any given day here, can we expect a pretty significant change in the weather? We can. Okay, that's what happens around here. If suddenly the wind shifts and it's out of the northeast, nothing good is coming from that direction weather-wise. Okay, that's going to bring cold, high-pressure air. Okay, because right here, this is always a high-pressure area. It's called the Siberian High. Okay, and over here is what's called the mother low. Okay, those two areas are always high and low pressure, but they can change in size. Okay, and they can move around a little bit, and that can change where our winds come from. And on Wednesday, I'll play meteorologist up here and show you how weather happens in our area by playing around on the map, just like the meteorologists do on TV. Okay? All right, tomorrow, bring with you your calculator. I only have 2 good ones to loan out. You are number 3. You are so out of luck. Okay? So bring a calculator, bring pencils. Okay? There's some numerical, some multiple choice, some written. Same as always.
Do you know if we can start early?
I will try to make that happen. We do have a staff meeting tomorrow, but I will try to be here to make sure we can start.